The topic is homogeneous equations. Let's do this example. Determine whether the differential equation y squared plus yx dx plus x squared dy equals 0 is homogeneous. If it is, solve it. So let's look at the definition of homogeneous equation. M dx plus n dy equals 0 is homogeneous equation if there exists alpha such that m of tx ty equal t alpha mxy and n tx ty equal t alpha nxy. So let's start with, first of all, this is my m of xy, and by looking at this equation, and this is my n of xy. So we know that m of xy is equal y squared plus yx, and n of xy is equal x squared. So let's verify this property. M of tx ty is going to be equal, y squared means the second component squared, plus y means the second component, which is ty, and then times x. X is the first component, which is tx. Now this is equal, just use algebra, t squared y squared, t times t is t squared, and then yx. What we can do here, if we factor t squared, we're going to get y squared plus yx, but just by looking at this is just right here. It's m of xy. So we just proved that there exists an alpha such that m of tx ty is equal to t squared m of xy. My alpha is right here, the exponent of t. So alpha is equal to 2. Now we need to do the same thing for n of tx ty. Now n of tx ty is equal, remember n of xy is the first component square, so this will be the first component square, that's the first component square, but this is just t squared x squared. So by looking, x squared is just right here, it's just n of xy. So basically we just proved that n of tx ty is equal to t squared n of xy. So this is my alpha. So the equation is homogeneous of degree 2. Now let's solve it. How do we solve it? It says that if it is homogeneous, use y equal u at to reduce it to first order, to separable first order differential equation. So let's use y equal ux. We always use y equal ux, and we always need the dy, always, for homogeneous equations. So the dy, product rule, this will be, the differential of y is just going to be u dx plus x du, right, by definition. So all we do is, let me rewrite the equation. The differential equation is y squared plus yx dx plus x squared dy is equal to 0. So I'm going to plug ux in every y, and then I'm going to plug dy here. So let's do that. So y is ux, so this becomes ux squared plus y is still ux times x, and all of this dx plus x squared, and the dy is right here, which is u dx plus x du, and this is going to be equal to 0. Now all I need to do is distribute. If you distribute this is u squared x squared, so u squared x squared dx plus u, x times x is x squared dx plus x squared u dx, and distribute, x squared times x is x cubed du. Now what's next? Next we always factor the dx and the du and see if there's anything that we cancel, Actually, these two are exactly the same, so there's two of them. So u squared x squared plus, there's two of them. I'm factoring dx in the same time. 2u x squared, all of this dx, and there's only one term with the du, x cubed du is equal 0. But remember, we know this is going to be a separables right here, separable first order dE. So how do separate? We need to separate the x's and the d and the u's. So here I have to separate them. So x squared factor of u squared plus 2u dx plus x squared x cubed du is equal 0. Now what else? So I'm going to leave all the u's as much as I can. The du is on the left side and the dx on the right side. So x cubed du is on the left side, and then the right side I'm going to do minus x squared u squared plus 2u dx. Now remember, we can move things on orthogonal this way or this way. It's not a problem. Let me rewrite the equation on the other page. X cubed du equal minus x squared factor u squared plus 2u and dx. So this x cubed gotta go to the other side, and this part gotta go this way. So du, so this will be u squared plus 2u, and then this will be equal minus x squared. I'm gonna move the x cubed this way, so this will be x cubed dx. Now let's factor the bottom. This is du over u factor of u plus 2. This is going to be minus 1 over x dx. And then the integral of the left will be integral of the right. We already separated them. Now you have to remember how to use fractions. To do this integral, we're supposed to let me do it here. 1 over u plus 2 is supposed to be equal a over u plus b over u plus 2, and all I need to do is find the a and the b. So what would this be equal? This is the same thing as a times u plus 2 plus bu over u times u plus 2. I'm just adding those fractions. Now see, the denominator is the same, so that means the numerator has to be the same, so which means a u plus 2 plus bu should be equal to 1. So how do I solve a and b? Let me just factor it. This is distribute au plus 2a plus bu is equal to 1. 1 is the same thing as 0u plus 1. Right? Now I'm factoring the u. A plus b factor of u plus 2a is equal to 0u plus 1. So this means that a plus b equals 0 and 2a equal 1, which means a is going to be 1 half and b is minus a, which is negative 1 half. So now I can rewrite this, so the a goes here and the b goes here. So now we have integral, the a is 1 half, so 1 half over u du plus integral of negative 1 half over u plus 2 du, and this is equal integral negative 1 over x dx. Now this is pretty easy. 1 half ln of u minus 1/2. Take the negative 1/2 outside, and that's ln of u plus 2 is equal to minus ln of x plus some constant. Try to simplify it more. Let me rewrite it first as 1/2 ln of u minus 1/2 ln of u plus 2 plus ln of x equal constant. If I multiply by 2, let's call this C1. So if I multiply everything by 2, I'll get ln of u minus ln of u plus 2 plus 2 ln x equals some constant c, and the c is equal to c1. Let me write it here. C is equal to c1. What else we can do? Now we can write this as 1 ln. So ln of how can I write it? So u over u plus 2 right, and then we can move the 2 here. This is the same thing as ln of x squared. So x times x squared is equal to constant. Forgot to plug in the u, so we need to plug in the u back. So this is ln of, remember the u is y over x, so y over x, x squared over y over x plus 2 is equal to some constant. Well, we can simplify this or just write e to all that. Well, first we can simplify x with dx and then do e to over left side, so that would be just the inside. The inside will be what? So that would be yx over, if you factor that, the bottom will be y plus 2x over x, and this is going to be equal e to the c. So let's finish it here. Now all you do is divide. Let me finish it here. Now that's going to be yx multiplied by x is x squared, yx squared over y plus 2x equal some constant, and c is just, let's call this, I don't know, c2. c2 is equal e to the c, doesn't matter. So that would be it, and that's it for this problem.